So in chemistry, there are three acids that are referred to as the acid holy trinity. And that is because 80 to 90% of the time when chemists need some acid in a laboratory, they use one of these three. So if you can get your hands on each of them, your laboratory acid needs are basically set. First, we have sulfuric acid, sold as battery acid / drain cleaner, used when an acid acidity strength, also known as pKa, is of utmost importance, or when water contamination can ruin a certain reaction. So, like for hydrochloric acid and nitric acid, the other two acids, they're sold in a solution with water, but sulfuric acid is sold as 98% strength, with only a tiny bit of water. Next, we have hydrochloric acid, stomach acid, sold as pool pH acidifier / concrete etchant. It's suitable for most organic chemistry applications, and it's used more than sulfuric or nitric in organic chemistry. And finally, we have nitric acid. Nitric acid is used to refine precious metals like silver and gold, which is what I'll be using it for. And it's also used to make fertilizer and used to make high explosives. Nitroglycerin, trinitrotoluene, also known as TNT. Why do you think all of these chemicals have the nitro in the group? It's because they're all made using nitric acid. And that is what I am going to show you how to make today. So I am going to be using the Birkeland eyde process to make nitric acid. So I'm going to explain that to you guys. Now, I'm going to explain the Birkeland eyde process, which is the process that forms nitric acid naturally in the old method of producing it industrially. So air is 98% oxygen and nitrogen in the form of O2 and N2. So here we've got oxygen 2 and nitrogen 2, and now we struck it with lightning in nature or an incredibly high voltage, and it breaks into free electron radical nitrogen and oxygen, which quickly combines into nitrogen oxide, which scavenges oxygen from O2 to form nitrogen dioxide, which is a brown gas. This is an indicator that the reaction is working because the chamber will turn brown from this brown gas. Then we bubble the brown gas through water, and this is the reaction. 3 nitrogen dioxide plus 1 H2O water creates 2 molecules of nitric acid and 1 molecule of nitrogen oxide. If we bubble it, meaning that we create nitric acid at a 66% efficiency. But if we bubble it through hydrogen peroxide, we can get an 100% efficiency. 2 molecules of nitrogen dioxide plus H2O2 hydrogen peroxide creates 2 molecules of HNO3. I am going to be compromising between bubbling it through water and high test peroxide by just using normal 3% medical peroxide. This way, the reaction will be more efficient in the beginning and whatnot, but it will lose efficiency towards the end, but I don't really care at that point. Anyway, that is the Birkeland eyde process summed up for you guys. To synthesize nitric acid, I am going to be using the Birkeland eyde process, which is used industrially. They have giant industrial Birkeland eydes that are used to make nitric acid to make all the fertilizers that the world needs. Anyway, I'm going to start with my power supply. This is the microwave oven power supply that I showed you from a previous video. I didn't make any major modifications, so it still has the overheating problem, but I am soon going to get a paint can and turn it into an oil-cooled transformer as soon as I can, so that I can run it for longer periods of time. Next, we have the electrodes. So the power from this goes down here, and this is the first electrode. I took all of my copper wires and I strung them into a single electrode that is nice and thick, and it's got a lot of heat dissipation, and it's a very good electrode. The second electrode is this pipe, and we can suck air down through it. So air comes in this pipe, and it goes up into this pipe, and it gets ionized by the electrical arc and turned into nitrogen oxides, which when bubbled through water produce nitric acid. So basically this holds the air in, and I've got this really old fish tank bubbler. It was from my grandma. She used to use it for her fish tank when she was little, so it's really old, but it works fine. I plug it in, and this fish tank bubbler works perfect. It doesn't have any problems really. It bubbles air up into this hole right here. The air goes up and it gets ionized by the high voltage, and then it gets sucked down and it gets bubbled through a container. This is the container that I am going to do the test run with, since it's nice and small, but eventually after I get it up and running I can move to bigger containers. They all have the same size cap, so I won't really have to modify this setup. I can just like press this further back so that I can fit bigger bottles. But anyway, yeah, it bubbles it through water or hydrogen peroxide. If you bubble it through hydrogen water, it will produce nitric acid, but it will produce it at a higher efficiency if you use hydrogen peroxide as a secondary oxidizer in the birkeland eyde process. It's not necessary. You can just use plain old water, but it will increase the efficiency if you use peroxide. And 3% hydrogen peroxide used for cleaning wounds and stuff is pretty cheap, so where I live, so I'm gonna use the peroxide instead of normal water. I really don't care that much. So anyway, yeah, this is my full setup. I filmed a video of me building it, but like I didn't really feel like editing that whole entire thing together. It was a bit much. So yeah, hope you enjoyed, and see you in the next video where I try this baby out. So it's important that you get a nice seal. I used a lot of rubber bands and stuff down here. It is very important you get a nice seal, because nitrogen oxides are pretty toxic, and it's also important to run this outside, since there will be some escape of nitrogen monoxide if you are bubbling it through water, or even hydrogen peroxide. Not even that process is 100% efficient in destroying the nitrogen oxides, converting them into nitric acid. But anyway, yeah, it is important that you run this sort of thing outside. Just gonna throw that out there. And high voltage is obviously very dangerous. Don't mess with it unless you have some experience. And one important thing about high voltage is that you always work with one hand behind your back, so that you don't grab something with two hands and electrocute yourself to death. Because if you grab something with two hands at the same time, it goes right through your heart. But if you're only using one hand, the worst thing that's going to happen is you get like harmed on the hand or something. So yeah.